Hello, welcome to Back to Coding. In today's practical, you will learn how to debug your app in an emulator, set and view breakpoints, step through your code and examine variables. Before we get started, don't forget to hit that subscribe button and a bell icon so that whenever I publish a video, you get notified instantly about it. For this practical, you want to build the simple calculator app yourself. The complete project is available at this URL. You can find the project Simple Calculator here. Click on this clone or download button and click download zip. The download starts. After you have finished downloading it, unzip the Simple Calculator project folder. Open the Simple Calculator project into Android Studio. If you face any issues while syncing the app, you need to make changes to the app levels Gradle file as shown here. First, let's explore the layout. Open the activity main.xml file. The layout contains two edit texts for the input, 4 button views for the calculation, and one text view to display the result. Each button has its own on-click handler: on add, on subtract, on divide, and so on. The text view for the result does not have any text in it by default. The two edit texts have the property Android input type and value number decimal. This property indicates that the edit text only accepts the numbers as input. The keyboard that appears on screen will only contain numbers. Second, we'll explore the app code. Explore the app/java folder. Here you will find, in addition to main activity class, this project also includes a utility calculator class. Let's see the calculator class. As you can see here that the operations the calculator can perform are defined by the operator enum. And all of the operation methods are public. Let's open the main activity class. Here you can see that all of the on-click handlers call the private compute method with the operation name as one of the values from the calculator.operator enumeration. If you control click on the compute method, you will see that it calls the private method getOperand, which in turn calls getOperand text to retrieve the number values from the edit texts. The compute method then uses a switch on the operand name to call the appropriate method in the calculator class. The calculation methods in the calculator class perform the actual arithmetic and return a value. The last part here updates the text view with the result of the calculation. Let's run the app. Select the appropriate device. Click OK. First, let's enter both integer and floating point values for the calculation. First operand as 24 and second operand as 2.35. Add, subtract, divide and multiply. It works perfectly. Let's enter floating point values with large decimal fractions. Example 1.67 5382 938. Add, subtract, divide and multiply. It works perfectly. And if we divide it by 0, it works fine. Now let's leave one of the edit text views empty and try any calculation. and click on this Run button. The app reports error and the system log displays the state of the execution stack at the time the app produced the error. It shows empty string. Now let's just run our app in the debug mode. Click on the debug icon and select the connected devices and click OK. Once the app runs, open the main activity.java file and click in the fourth line of the compute method. A red dot appears at that line indicating a breakpoint. Now on the device, enter numbers in the edit text views and click add. As you can see, the execution of your app stops when it reaches the breakpoint you set, and the debugger shows the current state of your app at that breakpoint. Let's examine the debug window. It includes the frames panel, and the variables panel. Both of these things are explained in detail in my Concepts Explained playlist. You can find its link in the description below. The frames panel shows the current execution stack frames for a given thread. As you can see, our app is currently running in the main thread, and the app is executing the compute method in main activity. The variable panel displays the variables in the current scope and their values. At this stage, the variables are this for the activity, the operator name from calculator.operator that the method was called from, as well as the global variables for the edit texts and the text view. To resume our app's execution, click this resume button. The app continues running until it reaches the next breakpoint. If your app is already running on a device or emulator and you decide you want to debug that app, you can switch an already running app to debug mode. You can first run the app by clicking the run icon. Second, click the attach icon to debugger. Then select your app's process from the dialog. Click OK, and now you can debug your app. Now let's explore the various features in the Android Studio debugger, including executing your app line by line, working with breakpoints, and examining variables. First, we'll see the step functions. Let's debug our app and enter some numbers here. As you can see, the execution has stopped here. Click the Step Over button. The debugger executes the current line in the compute method, that is the operand 1 line, and the highlight moves to the next line in the code, that is the assignment for the operand 2. The variables panel updates to reflect the new execution state, and the current values of variables also appears after each line of your source code in italics. Now click the Step Into icon. Step Into jumps into the execution of a method call in the current line versus just executing that method and remaining on the same line. In this case, because that assignment includes a call to get operand, the debugger scrolls the main activity code to that method definition. When you step into a method, the frames panel updates to indicate the new frame in the call stack, here get operand, and the variables panel shows the available variables in the new method scope. Click the Step Over to run each of these lines in get operand. Note that when the method completes, the debugger returns you to the point where you first stepped into the method, and all the panels update with the new information. Use Step Over until you get inside the case statements for add. Then click Step Into. The debugger executes the add method defined in the calculator class, opens the calculator.java file and scrolls to the execution point in that class. To pop back out to the compute method in main activity, use the step out icon. Next we'll see how to work with breakpoints. First let's find the breakpoint that we set in compute method. Let's add a breakpoint to the start of the switch statement. Right click on that new breakpoint and enter the following text in the conditional field. Operand 1 is equal to 42 or operand 2 is equal to 42. Click Done. The second breakpoint is a conditional breakpoint. The execution of the app will only stop at this breakpoint if the test in the condition is true. In this case, the expression is only true if one or the other operands we entered is 42. Let's try it. Run the app in debug mode and enter two numbers other than 42 and click the add button. Execution halts at the first breakpoint. Click Resume. Observe that the execution did not stop because the condition was not met. Now right click the first breakpoint and uncheck Enabled. Click Done. Observe that the breakpoint icon now has a green dot with a red border. Disabling a breakpoint enables you to temporarily mute that breakpoint without actually removing it from your code. If you remove a breakpoint altogether, you also lose any conditions you created for that breakpoint. So disabling it is often a better choice. You can also mute all breakpoints in your app at once with the Mute Breakpoints icon. In the app, enter 42 in the first edit text and click any button. Now the execution halts. Click the View Breakpoints icon. The Breakpoints window appears. The Breakpoints window enables you to view all the breakpoints in your app, enable or disable individual breakpoints and add additional features of breakpoints including conditions, dependencies on other breakpoints and logging. Click Done. You can also examine and modify variables. Simply run the app again in debug mode and enter two numbers, one of them 42, and click the Add button. Execution stops. Observe in the variables panel that the operand 1 and operand 2 variables have the values you entered into the app. Observe that this variable is a main activity object. Click the disclosure arrow to view the member variables of that object. Right click the operand 1 variable in the variables panel and select Set Value. Change the value of operand 1 to 10 and press Return. Modify the value of operand 2 to 10 and in the same way and press Return. Click Resume icon. You'll see that it shows 20. In the app, click Add button. Execution halts. Click the Evaluate Expressions icon or select Run Evaluate Expressions. The Evaluate Code Fragment window appears. Right click on the operand 1 and choose evaluate expression. Type m operand 1 edit text dot get hint and click evaluate. As you can see, the evaluate expression window updates with the result of that expression. The hint for this edit text is string type operand 1. The result you get from evaluating an expression is based on the app's current state. Depending on the values of the variables in your app at the time you evaluate expressions, you may get different results. Click close. That's it for this video. I hope you enjoyed this tutorial. Please give it a thumbs up and share it with your friends. Don't forget to check my other videos which can be helpful to you.